Pose semi-supervised classification as simpler. Optimization. Abstract. This article discusses if we can pose semi-supervised classification as simpler optimization or not. Furthermore, it proposes the novel approach to effective optimization for kidney donation, posing semi-supervised classification as the quantity of patients on the holding up records far surpasses the quantity of accessible organs. Proposed method uses semi-supervised classification as it has higher efficiency as well as it reduces efforts of labeling, so it can be posed as simpler optimization. Keywords: labeled data, semi-supervised classification, optimization, unlabeled data, donors, semi-supervised learning, living donor, support vector machine, classification, supervised learning, unsupervised learning. Introduction. The task of assigning a training examples to just an input design is known as classification. The class label shows one in everything about a custom arrangement of classifications. With the assistance of a model GOT utilizing a learning technique, the classification is done. There are two types of categorization based on the type of training utilized: one, exploitation supervised learning, and therefore the alternative, exploitation unsupervised learning. Semi-supervised learning classification comes between these two learning classifications. Semi-supervised learning is a machine learning strategy that blends a big quantity of unlabeled data with a small quantity of labeled data throughout preparation. Semi-supervised learning comes amid supervised learning, through only training data that has been labeled, and unsupervised learning, with no training data that has been labeled. The essential objective of semi-supervised classification is to use unlabeled information for the development of future better learning strategies. The most basic semi-supervised teaching process is self-training. Building a classifier and using labeled data is involved in this. This is used to categorize data that hasn't been labeled. The sample is picked from the unlabeled set with the sharp peak and added to the labeled data with all of its tag. Repeating this step will increase the size of the data set. Furthermore, the graph convolution network model learns illustration of a buried layer that encodes both feature of nodes and local graph structure. Its gravimeters increase in frequency of input patterns in a linear fashion. Likewise, multi-view grouping and semi-supervised classification with versatile neighbor S model can apportion consequently ideal load for each view without extra weight and penalty boundaries. It is critical to optimize a living kidney donation program in order to ensure a high level of acceptance among potential donors. For people with later part kidney failure, kidney transplantation is normally the only option. However, the availability of kidneys is much insufficient to meet the rapidly increasing demand. As optimization cannot handle huge data, lots of patients suffer from lack of kidney donation. Furthermore, semi-supervised classification can work in less labeled data, so it will be useful to optimize more kidney donors. 2. Literature survey. A fast quasi-Newton method for semi-supervised SVM. Sathish Reddy, 2011. According to Reddy, 2011, because of its wide relevance, semi-supervised learning is a beautiful technique for utilizing unlabeled data in arrangement. Within the research article, a semi-supervised SVM classifier that is based on the semi-Newton procedure for semi-curved capacities is presented. The projected algorithm is appropriate in handling terribly large number of examples and options. The proposed algorithm is fast and improves generalization performance over current approaches, according to mathematical research and studies on various criterion data sets. A quasi-semi-supervised support vector machine centered on a numerous attribute shift theme has also been projected. On a few touchtone data sets, such non-straight quasi-SVM is observed to collect data faster and increase speculation execution. Hence this paper proposed that this quasi-Newton method is very suitable to deal with huge numbers of examples and features. B. A unified dimensionality reduction framework for semi-paired and semi-supervised multi-view data. Chen, Xue, and Zhou, 2012. According to Chen, 2012, canonical correlation analysis, CCA, is a famous as well as incredible extent decrease technique to break down matched multi-perspective information. Nevertheless, whenever confronted with tractor-trailer and semi-supervised multi-scene experience, such as that seen in actual issues, CCA will underperform due to its requirement for information coupling between very opposite viewpoints and the lack of oversight inherent in nature. Furthermore, for various real-world application it is a key step to learn an expressive representation from multi-view data. In view of the structure, we tend to build up a special spatial property decrease strategy, named as semi-paired and semi-supervised generalized correlation analysis, S2GCA. S2GCA exploits a tiny low quantity of paired knowledge to carry out CCA and at constant time, exploits each world structural data acquired from the untagged knowledge and also the native discriminative data captured from the restricted labeled knowledge to compensate the restricted pairedness. Moreover, to capitalize on the information boasted in unlabeled data, a semi-supervised learning framework is designed by merging density clustering and deep metric learning. When compared to existing connected spatiality reduction strategies, testing findings on ephemeral and for actual datasets display that it is more effective. See a flexible convex optimization model for semi-supervised clustering with instance-level constraints. Ren, Wang, and Zhang, 2011. According to Ren, 2011, clustering is a typical errand in numerous applications. E.g. bioinformatics and optical image processing. Many methods have been suggested, including k-means, expectation maximization, and parameter variations. Semi-supervised clustering is clustering method that can be applicable to partially labeled data. In this paper, we extend further the model in the semi-supervised setting. It has three salient characteristics. Clustering algorithm can run on unlabeled data as well as labeled data. Already labeled data and newly labeled data are used for classification. The predominant category of all the points in a cluster is used to mark all or most of the cluster centers. In each cluster all the points are labeled by majority class of cluster. Furthermore, this model can then be outstretched to explore the hard binary clustering and multiple clustering problems by a few refashioning. Experimental studies from both virtual and actual data sets show that this approach is successful. De-optimization approach to semi-supervised learning. Demirais A., 2001. According to Demirais, 2001, the examination of numerical simulations for semi-supervised support vector machines, S3VM, is done. Provided a coaching set of labeled data as well as an operating set of unlabeled information, S3VM creates a support vector machine by combining the coaching and dealing sets. S3VM is used to address Vapnik's transduction inference issue. The goal of transduction is always to evaluate the value of a classification execute at certain moments throughout the operational. The S3VM system for one norm planar SVMS regenerates to a mixed integer program, MIP, is the major attraction. A world answer of the MIP has been discovered employing a business whole number programming problem solver. A pultruded quadratic method is used in second process. A variety of block coordinate descent algorithms square measure want to realize native quick fix for this drawback. Victimization. This MIP at intervals and area learning formula made the simplest conclusions. Integrating operating knowledge promotes applicability, according to our experimental investigation upon those applied mathematics literacy methodologies. Semi-regulated classification of time series. The developing interest in time arrangement classification can be credited to the arduously expanding measure of worldly information gathered by boundless sensors. This diagram depicts the effect of unlabeled data in semi-supervised learning. The upper part denotes a decision boundary we can embrace after seeing only one negative, black circle, and one positive, white circle, example. The lower part denotes the decision boundary we can embrace if, the two labeled examples in addition, a collection of unlabeled data were given. This could be seen as performing bunching. Clusters naming with marked information, choice limit moving drove away from high density area. Optimization and Simulation of an Evolving Kidney Paired Donation, KPD, Program. Lee, et.al., 2011. The tragic fact that potential contributors, including identical living donors, are frequently inconsistent with their beneficiaries due to ABO blood group incongruence and/or immunity contrary to a number of donors' human leukocyte antigens, is a major issue with living donor kidney transplants, HLA. A and B contributors can only bestow to recipient for co-equal genetic profile or type of backers can solely contribute to a recipient, and O donors, also known as regular donors, can contribute to anyone. The presence of anti-donor antibodies in a candidate's blood is the second type of incongruity, likewise referred as a favorable cross-match. 3 proposals. The scarcity of organs is a worldwide problem. The estimate of patients who are waiting for kidneys far outnumbers the eligible organs. Several programs have been launched in most European countries to raise the number of living organ kidney transplants. To increase the search of available donors, I propose to use semi-supervised classification, which is posed as simpler optimization for better results. For unlabeled data, brain-dead patients in the hospitals can be taken. It can be taken as unlabeled data as we don't have acknowledgement of their health issues, blood groups, matching receiving pair, etc. By using this labeled and unlabeled data with semi-supervised learning, we can classify huge data to reduce shortage of kidney donors. See increase efficiency of semi-supervised learning. 1. To increase efficiency of semi-supervised learning along with its accuracy, clustering algorithm can be used as it provides better insights and helps to train a better classifier. For conclusion. According to above paper and research, it came to conclusion that we can pose semi-supervised classification as simpler optimization problem. As the semi-supervised classification problem reduces the required efforts for labeling efforts, it can be posed as simpler optimization problem. Nowadays machine learning is continuously emancipating its power in wider range of application. There is huge opening for semi-supervised classification as it offers more accuracy in classification. It is fleetly evolving technology which offers great potential in classification. Furthermore, this method also used for effective kidney donation optimization, as huge data can be classified effectively in less time and help can be provided on time to needy patients.